Morning, everyone. I guess it's time to get started now. My name is Eric Brandwine. I'm with the AWS security team. Many moons ago, when we started the AWS office in Virginia, we were standing around in what used to be a closet and was now our new office in front of a whiteboard. And we were brainstorming ways that we could bring the joys of AWS to enterprise and large customers. And one of the things we wrote down was conference. And that was met almost universally with giggling, because like, why would anyone want to go to an AWS conference? And here we sit, or stand, at an AWS security conference. And it is absolutely amazing to me that we have reached this place. It is humbling that you have all chosen to take time out of your busy schedules to come visit us in Boston. And I'm really excited that we get to be here today. This is the Security Pioneers track. And what's a security pioneer? That was a question I didn't have a ready answer to. And I was thinking about it. And a few years ago, the family and I were in Seattle, and we went to the Living Computer Museum. If you are ever in Seattle, or heaven forbid you live in Seattle and you've not been to the Living Computer Museum, you should go. It is amazing. Upstairs, they have everything. We played chess against a PDP-11 over a teletype. I lost. My kid got to punch his name out in EBCDIC on a punch card, like an actual honest-to-God antique IBM punch card. It was a great experience. And for me, this was a walk down memory lane. This is, stuff that I used to deal with. But for him, everything was new. And we wound up in front of a Macintosh SE 30 that he thought was super cool and I thought was super antiquated. And it was playing the Oregon Trail. So we sat down and we played through the Oregon Trail. And again, for him, this was new and exciting. For me, it was a throwback to childhood. And it was a great game. It was exactly the way I remembered it. But as so often happens with kids, they're lacking in context. They don't know the things that we all know. And so we started asking questions. And one of his questions was, why on earth would anyone go on this trip? Like, broken legs, dead oxen, short rations. Like, there's no reason to go on this trip. Why would you be a pioneer? And this led to a fascinating conversation. And it turns out that there were huge rewards for being a pioneer. The risks were huge, but the rewards were huge. So I talked about this a few years ago at reInvent. Our modern world, with all of its conveniences and safety, is, on genetic timescales, a rounding error. We evolved in a world where Arctodus Simus was running around. And so fear and caution, distrust of the unknown, those were survival traits. We have been genetically selected over generations to be a little bit reticent when faced with something new. So caution and a retreat to the familiarity in the face of uncertainty, those are usually good. And that applies just as much to technology, to modern humans, as it does to cave bears. So the vast majority of customers, of companies, of people, in the vast amount of things that they want to do, don't want to be first. Maybe if it's what you do, if it's core to your business, you make widgets, you're going to lean forward on that new widget press. But there's huge risks in exchange for those huge rewards. However, you also don't want to be one of the latecomers. You don't want to be trailing behind. The risks and the rewards are lower, but you're going to be facing higher migration costs. You're going to be facing deprecated technologies, self-support. And so most customers wind up on most things wanting to be in the middle of this spectrum. Effectively, this is an optimization exercise. It's our contention that this is not a zero-sum game. That is, you can both increase the rewards and decrease the risks that you face. So let's dig into how we think about this at AWS. As we've discussed, we've always been hesitant when faced with new things. And for years, this was the conversation that we as an internet were having about the cloud, about AWS, about pretty much every new thing that comes along. I recently discovered the most wonderful Twitter feed, the Pessimist's Archive. It's about new technologies that were going to ruin society. One of the ones I just read was how bicycles were going to spell the end of bookstores because you can't read a book while you're riding a bicycle. That doom didn't come to pass, as so many others didn't. And luckily, for AWS and for humanity in general, we have explorers. We have people that get on ships when a sextant is the most advanced navigational technology we have. We have people that are willing to get on bicycles despite the demise of the educational system. And the whole technology field as a whole tends to be disproportionately densely packed with explorers. At AWS, we love our exploring customers. Here's a bunch of use cases from customers in AWS. These customers break ground, they solve hard problems, they help us establish patterns that work, and perhaps most importantly, they drive us to improve our services and features so they really do support challenging, valuable use cases. This is a small selection of our customers, and look at the variety of use cases. Travel, banking, ride sharing, media, e-commerce, all running on AWS. The first settlers to the Willamette Valley in Oregon had a long, hard, painful trip. So did the second settlers, so did the third settlers. Slowly, very slowly, over the course of years, lessons were learned, gear was improved, better roads were made, but the progress here was incredibly slow. In traditional IT, this has often been the case. I have worked in traditional data centers. I remember racking and stacking boxes and trying to figure out, like, where is this one going to go and do we have enough power for it? Things like that. Capital had to be allocated, vendors had to be selected, infrastructure had to be built. Replicating the lessons from one project to another project was challenging, but even more challenging was taking the lessons learned from a project and retrofitting it to an old project. You might not have the hardware in place, you had all of these invasive change management procedures, CMs, things like that. And so these changes became difficult, they became expensive, they became fear-inducing. And so more and more stacked up on the change, which made the change take even longer, which made more stack up on the change, which decreased the odds of the change succeeding or even occurring. And in AWS, as we learn lessons, as our customers teach us lessons, where we can, we build those lessons directly into our services. Sometimes this is new features and new functionality. Sometimes it's quieter than that. Improved performance, improved latency, higher availability. These things are available to all of our customers immediately without risky deployments, without complex change management. And on top of our services, there's this growing library of best practices, design patterns, and best of all, CloudFormation templates, which are design patterns and best practices captured in a repeatable computer executable format. Leaning forward has never been easier, and that's true of security in AWS as it is in so many other ways. And so now the conversation has changed. This is the conversation we have with the majority of our customers now. How do I secure my cloud? How do I move faster? How do I enable my teams better? Which customers have been there before me? So let's look at one of the examples here. This is a slide from the Nitro deck. Nitro is the new droplet, new physical server architecture we have in EC2. And this was a long journey. We started off with a traditional hypervisor. We ran our control plane in what Zen calls DOM0. It was all x86. And we've started offloading functionality. With C3, we offloaded network functions. With C4, we offloaded EBS. And with C5 and the other Nitro droplets, Nitro instance types, we've offloaded the entire AWS control plane. And so 100% of our software is operating outside of the x86. That's enabled us to build our own motherboards, to control the x86 boot process, to manage firmware much more carefully. And it's this technology that allows us to launch bare metal instances. We can confidently give a customer a machine with absolutely no AWS code running on the x86, take that machine back, ensure that it is baselined and posture assessed correctly, and then give it to the next customer. This is amazing technology. It's the kind of thing that we used to dream about. If only as a cloud builder we could have these things, and we've delivered it. And if you look at the risk-reward trade-off here, you get increased security, increased isolation. The performance consistency is much, much better because we've offloaded all of those functions. We're no longer stealing cycles from your guest. But if you look at the downsides, literally one API call, change a parameter and run instances, and you can launch one of these machines. This technology is available to you. And while I was digging for this, it's 8.5 cents an hour for a C5 large. When we launched AWS, it was 10 cents an hour for an M1 small. So a Nitro instance actually costs less than an M1 small did when we launched. And so with this, you can try it out quickly, you can evaluate it. If it works, Then you need to scale up, you need to go to production. It's not without effort, it's not instantaneously free, but the downside here is incredibly low. If you want to eliminate any possibility of risk due to a hypervisor, you can launch one of our bare metal instances. Less than $5 an hour. And so you can evaluate this technology today, right now, and if you don't like it, you pull the plug, the billing stops, and you're left with no residual there. So you can lean forward on this with low risk. Another example that we have is GuardDuty. Hopefully, you have all heard about GuardDuty at this point. Hopefully, you've all tried out GuardDuty at this point. GuardDuty is our threat detection service that continuously monitors for malicious activity and unauthorized behavior in your AWS accounts and workloads. There's a ton of complexity behind AWS GuardDuty. We have multiple data sources that we have to manage, ingest, ETL, normalize, and then correlate at scale. And to give you an idea of the scale here, we've turned off a bunch of our custom internally developed security tooling that we use to secure our own AWS deployment in favor of GuardDuty. And our internal account management system manages, it's a significant fraction of 1 million accounts. It's a 6-digit number. And so just to support AWS, not Amazon, AWS as a customer, GuardDuty has to parse all of the flow logs, all of the DNS logs, all of the CloudTrail logs for a significant fraction of 1 million accounts for one customer. And we have to do this at low cost. Once we've got the data flowing, we need to analyze it, we need to have the detections, we need to have the machine learning models. There's a ton of stuff behind GuardDuty that we had to do to make the system scalable, performant, cost-effective. There's a lot to be proud of. But the thing that we're proudest of is the customer experience. Turning on GuardDuty is literally just a click in the AWS console. It's basically saying, yes, I would like to try out more security. GuardDuty launched with 29 distinct detections. And Steve stole my thunder in the keynote. We did a bad job of coordinating here. We're up to 54 now. That's an 86% increase. In order for our customers to take advantage of that, they had to do nothing. Those new detections were immediately available for all customers that were using GuardDuty. And we did this without increasing cost. In fact, as Steve mentioned, average customer cost for GuardDuty has gone down by 28%. And so this is an opportunity to push forward, to ride close to the explorers, close to the front, with very little risk. And so, again, one-click security, deeper visibility into your AWS accounts and your workloads, a constant stream of new detections, the application of machine learning to security. And GuardDuty does all of this using data sources that we're already collecting from the AWS infrastructure. Turning on GuardDuty will cause 0 microseconds of additional network latency. It will cause 0 megabytes of server memory to go wasted. It will impact your production not at all. There's no agents to manage. There's no change to your workloads. The only downside here is cost, which isn't much of a downside because GuardDuty has a 30-day free trial. And so again, this is a really easy decision to make. Now, I work for AWS. I'm wearing a shirt with an AWS logo. I am a biased party in this conversation. We're really proud of what we built. We think that you'd like it. We would love for you to use it and give us feedback on what you think. But there's a broad array of partners that can help you out here. They have service offerings that integrate with AWS. Some of these names are new. They're born in the cloud. Some of these names you've been using for years in your own facilities. And they're easier to evaluate and easier to deploy in AWS than they are on premises or anywhere else. Using CloudFormation, you can deploy 2 identical VPCs, one with one firewall vendor, one with another firewall vendor, and you can do a head-to-head comparison between the two, decide which one you like, and when you're done, you pull the plug, and you're left without any hardware, without any firewalls that you need to figure out what to do with, without any racking and stacking tickets. We talk a lot about having building blocks in the cloud. And we're constantly adding new capabilities, infrastructure security, new encryption options, Security Hub just GA'd, traffic mirroring, which I'm incredibly excited about, Resource Access Manager that allows you to share resources across accounts. But let's get into what we mean when we say building blocks. We're going to talk about a combination of 3 of the security services plus Lambda and EC2. And what happens, there's some event, some occurrence in the cloud, and that's going to result in the arrow is disproportionately large. That is going to result in a log message, some sort of record of that event. And if you've got guard duty enabled, guard duty is going to pick that up, it's going to do things, and that's going to generate a finding. If you've got Security Hub enabled, Security Hub will pick up that finding, it'll normalize it, it'll correlate it with other findings, and it'll put that on the CloudWatch event bus. And CloudWatch events is awesome because it's basically turning anything that happens in the cloud into a programmable hook. Now, you don't have to use guard duty. You can use other security tools. Again, partners, vendors, things that you write yourself, things that you've already written, you can hook into this. And you can feed these findings into Security Hub. In fact, just in the hallway before this meeting, I was having a conversation with a customer that's done just this. It's incredibly exciting to hear this. And then from CloudWatch events, you can feed this into your existing SIM or your new SIM or the SIM that you're evaluating. You can route to multiple destinations. But my favorite place to route things is Lambda. Lambda is our cloud function service. It's our serverless execution service. And so you write a little piece of code. We take care of all of the plumbing. You just need to write the function that accepts the event and decides what to do with it. And you can do anything that you can convince a computer to do. You can loop back and make an API call, or you can branch out to literally anything that you can make a computer do. And so one way to look at this diagram is there's a ton of complexity here. It's a complex diagram, and you keep adding things, and this diagram gets more and more complex. But there's no interesting, non-trivial system that doesn't have some complexity in it. If it didn't have any complexity in it, it would be neither interesting nor non-trivial. And so you're eventually going to wind up with complexity. It's unavoidable if you're solving challenging problems. The question is, how incrementally can I tackle this complexity? All of the yellowish-orange boxes here are AWS infrastructure. These are things that just happen. You don't have to do anything for them. The gray boxes are AWS services that you can enable with just a click. The blue boxes are things that you write yourself, things that vendors supply. And there the range of integrations varies. But you can add these boxes one at a time. And you can learn about them. You can become confident in them. And once you're confident, you can tackle the next box. So there's a lot of complexity here, but it's very incremental complexity. And to make this real, this is the CloudWatch UI. This is creating a CloudWatch rule. So we've got a service dropdown on the left here. And so we've got a selector for findings from guard duty. And on the right, we've chosen the Lambda that isolates, network isolates, stops an EC2 instance. And so you go through this one single pane, and now when a certain guard duty finding fires, the EC2 instance that was implicated gets stopped. And so that's it. There's all the complexity you need to tackle in order to complete that task. And so you can then proceed step by step as you identify things that you need to automate in the cloud, and you can tackle the complexity incrementally. And we can look at a couple of the finding types here in guard duty. Maybe you want to know when someone goes off script, when someone changes network access permissions, and then you can have a Lambda hanging off of that, and it can page someone, or it can send them an email with our standards for how you make network changes, or it can revert the network change. There's an opportunity here to take action. Likewise, changing the password policy. This is an unlikely event. It should be locked down in IAM, but if it happens, you probably want to know about it. Maybe it's enough just to know about it, to cut a ticket or something like that. Maybe you need to take some other action. Maybe you need to route it for approvals before you need to know whether or not it needs to be rolled back or not. And so you can do all of these things incrementally. And there's a ton of integrations with these services. These are, again, companies that you might have been using for years, companies that were born in the cloud, and they can help you out here. They integrate with these hooks. They become part of the building blocks, and you can stack these blocks up and decide whether or not you like the way they're stacked and restack them and get a couple new bricks and design the system piece by piece the way you want it. So looking at the risk-reward trade-off here, and I have to admit that I love this. Like, if you haven't played with Lambda, just like the Living Computer Museum, you really should play with Lambda. It's addictive. Like, the amount of code you write compared to the amount of benefit you get out of that code is disproportionate. And we do this. We run hackathons. We do this internally. We do this with customers. A hackathon is basically where you leave a bunch of developers with laptops and pizza in a room and lock the door. And we have never failed to have interesting, clever, non-obvious ideas pop out of this. Just a group of developers for an afternoon. And so you get rapid experimentation, you get rapid iteration, you get head-to-head comparisons. You can do A/B testing where you don't have to turn off the existing system. You can route your CloudTrail logs, your events to 2, 3, 4 systems in parallel. Each of them can perform some piece of useful work. You can evaluate one of them. You can add and remove destinations quickly. There's no big bang migrations. You can have A, you can turn on B, you can make sure you like it, you can turn off A, you can leave A and B both enabled, you can roll back very quickly. When we're making decisions at Amazon, we talk about one-way doors versus two-way doors. You go through a one-way door and you're done. You go through a two-way door, you can make up your mind as you learn more, as you accrete more wisdom, and go back through the door and make a different decision. And almost all of these decisions are two-way doors. And so you're basically down to the time you've invested. And so you get this benefit. And the minimum investment of time is literally a developer for an afternoon. There's a whole ecosystem that's built up around this. A lot of this material comes directly from AWS. Everyone has seen Jeff Barr's blog and all of the various venues we have for sharing information with our customers. But a lot of it comes from the community. As people learn about things, as they invent clever solutions, they share them and they make them available. And so many of these blog posts say, and here's the CloudFormation template, here's the AMI. It's available for you to use immediately. Some of it comes from individual builders, and some of it comes from partners. But regardless of where it comes from, there's the whole ecosystem out there helping you to follow the explorers, to safely be early adopters, and to position you such that when you encounter a new situation, a new challenge, something that you uniquely need to challenge, to solve, you can jump forward and become an explorer yourself. Artificial intelligence and machine learning. You can't talk about security without talking about them. And they're buzzwords, and we've been hearing about them literally for decades. But we live in an amazing time where a combination of advances in algorithms and the software to run them, plus a massive jump in the computing power available via GPUs and ASICs, and we're starting to see some of the amazing things that we've already been told about actually materializing. And I say starting because despite the fact that these things are materializing, we believe that we've still yet to see the bulk of the impact of ML. We believe that every field is going to be affected by ML deeply, and that doing it well will be core to success in the future. And of course, security is one of those fields. Security is a big data problem. We all deploy these large infrastructures. They accrete complexity. You've got logs coming from many sources. There's tons of data available. And extracting the signal from that noise is becoming more and more important as these things scale up. And data lakes, the availability of data, the ability to pool data together, and then the access to that, it just generates more and more and more data. And being able to manage that data and extract value from that data is central. So in addition to all of our services for hosting, managing, and operating on big data, AWS is the best place to start or continue your machine learning journey. And to motivate this, we've got a couple of customer stories here. GE has been using X-ray technology since 1896. I love that fact. We are helping them revolutionize a technology that is over a century old. They are feeding large volumes of medical imagery through machine learning models, and they're beginning to automatically extract indicators of health issues without having human beings look at them. And they're getting some stunning results in terms of accuracy and recall. And one of the cool things about this is as the models improve, they're able to reprocess images from the past and to detect problems that were previously undetectable. And the goal here is to help radiologists prioritize patients needing the most attention, to do automated triage to make sure that the health issues that are actually most acute are the ones that jump to the front of the queue. Likewise, Convoy, in a tremendously different application. More than 95 billion highway miles a year are traveled by trucks in the United States. And of those miles, about 40% of them are traveled empty. And so this is a complete waste of time and money and fuel. And so Convoy is analyzing all of the offers, all of the requests, all of the capacity, all of the GPS tracks from the trucks. This is a hard problem, and they're using machine learning on AWS to be able to determine optimal scheduling to match up trucks with loads to drive down the wasted mileage rate. So we've all heard the buzzwords, but my point is that we're getting past that into real utility. So one use case from inside of Amazon, we all have all of these cool new devices, and these cool devices all require a lot of power. The energy density of a modern lithium-ion battery is fairly spectacular. And most of the time, this is fine. But when lithium-ion batteries have problems, the pack gets punctured, it's manufactured incorrectly, it can smoke, it can heat up, and in the worst case, it can burst into flames, and maybe someone can get hurt. So there's actual human risk here. At Amazon, we sell things that have lithium-ion batteries in them. And we want to remove unsafe items from our catalog. And we've always had a program around this. And with lithium-ion battery issues, we were reactive. We were following along. We were making sure that we knew about products that were having issues. We pulled them from the catalog. But this is a case where customer trust is at risk. Safety is incredibly important, and we wanted to try and shift ourselves more proactively. You can see that there's a list of 3 names there. I'll get back to that in a minute. So what we managed to do is we managed to drive our rate of pulling items from the catalog from less than 10% to over 80% using machine learning. This was a difficult, challenging problem. And the goal here was when there is a report about a device anywhere in the world, we wanted to have already pulled that device from our catalog predictively. That's the goal. And so there were sources from all over the world, natural language sources, regulatory reports, things like that. There was a tremendous amount of working through natural language processing, extracting data, trying to tie that back to items in the catalog, a ton of experimentation, going back to the data, scrubbing it, cleaning it up, putting it through. There were 30 million pieces of feedback in various languages from all over the world. And we wanted to be near real-time responsive on this. If there was a report of something somewhere in the world, we wanted this pipeline to complete in a timely fashion so we could make a business decision about whether or not a product needed to remain in the catalog. And there was a lot of complexity in here. There was a ton of work that this team did, but it was 3 names. And so we did indeed wind up with a team of machine learning experts. But that team of machine learning experts, 1, it was small, and 2, they were focused on the machine learning. They were focused on algorithm selection, hyperparameter tuning, on making their models better. They were not focused on hosting models, on deploying models, on managing GPU farms. They were able to spend their time on what made their business uniquely different. This is the standard ML marketing slide. We've got tons of features here, all the way from the lower level where machine learning experts hang out, the base building blocks, all the way up through our higher level services that do things like automatically doing facial recognition out of video or natural language processing of text or audio. Tons of stuff here, but the way that I think about this stack is somewhat differently. On one end, we've got guard duty. This is incredibly easy to adopt. It is the easiest way to apply machine learning to a security problem. It's still, to me, the single best security click that you can make. But it's constrained. You get what guard duty does, and what guard duty does is really valuable, but it's just what guard duty does. On the other end of the spectrum, we have raw compute. We've got our P3 instances with top-of-the-line NVIDIA GPUs in them. We've got elastic inference and elastic GPU, so you can do low-cost inference. And if you've got a team of machine learning experts, if you've already got an investment here, this is where you want to be. On top of that, we have support for all of the popular frameworks in machine learning. And so if you've already got an investment in development, but you don't want to own the infrastructure, again, this is where you want to plug in. This is where you want to be. And we have specific AWS enhancements in these frameworks so that you get the best possible performance, not just the best possible performance on AWS, but the best possible performance anywhere as you scale up to multiple GPUs and larger models. But for me, the most important part of this is SageMaker. SageMaker is a fully managed service that covers the entire machine learning workflow, from algorithm selection, data cleansing, model generation, model hosting, deployment, and inference. And so this has taken the complexity of machine learning, and it hasn't eliminated it. As you go through your machine learning journey, you are going to wind up with more and more expertise here, and you're going to wind up with more and more complex systems. But it's turned it into a series of steps where you can incrementally adopt the complexity. I was at a dinner with a customer last night. I ran into a former coworker, and we were chatting. And my standard question whenever I'm talking to a customer is, how has AWS failed you recently? Like, I'm sure, I hope that all of you have positive things to say about AWS, but the most valuable feedback we can get is, how is AWS not meeting your needs? What can we improve? And I asked her this standard question, and she told me that SageMaker is awesome. Like, she completely failed to answer my question. And it couldn't have been better timing. So she had a team of 2 developers that was trying to tackle a data analysis problem. And these 2 developers, in a week, that had no prior machine learning expertise, were able to go in, get the right data, get the right algorithm, train a model, and deploy a prototype that was producing interesting, meaningful results. And so it was awesome to hear that feedback directly from a customer. Another example that we have is Coinbase. I believe Bitcoin just recently broke $10,000 again. When you go into a bar and you get carded, like, there's only so many American driver's licenses. The bouncer's going to look at it. Maybe they've got the UV light. They're going to check your identity. This happens at the airport. This happens at the border. We're pretty good at that. Online, checking IDs is much harder. And what Coinbase has done is they've used SageMaker to develop an algorithm, to develop a model that takes the images of the IDs, and this is the image of the entire ID, and it extracts out any faces that it finds on that. It normalizes those faces, and then it runs them across the catalog of every face from every ID that has ever been submitted to Coinbase. And they do this because it's hard to fake an ID. It's hard to create a face from scratch. And so they look for facial similarity across the IDs, and using that, they're able to find scammers that have used the same face on multiple IDs. And this has enabled them to catch up with forgeries. And so the reward here is incredible. Like, the things that people are talking about doing with machine learning is science fiction. It's the kinds of things they were making movies about a couple of years ago, and now we see news stories about them every day. And on the downside, you will eventually wind up with a team of ML experts if you invest here. But without clear value on the table, without an idea of what you're doing, it's much harder to justify hiring these people. Your direct personal experiences with what's possible are much more valuable than any amount of reading, any amount of research. And so it's tough to justify without that direct personal experience. Because the complexity with machine learning and Amazon is incrementally tackleable, you can start small. You can have a team go. They can do something in your application with your data and provide real value to your teams or your customers. And you can learn where it is and isn't applicable, and where there is and isn't value, and how much that's worth to you, and then start your investment. You can dip your toe in the pool without having to jump in whole cloth. And eventually, as you grow, as it becomes valuable, you'll start to bring those experts on board, and we will have the tools available for them as they want to dig deeper. This isn't free. You're going to have to spend time, but the risks that you're facing here are much, much lower than if you had to buy a GPU farm, hire a bunch of machine learning experts, and wait 6 months for the first results. Quantum computing. This is one of the most interesting topics in computer science, period. It is a fundamentally new way of computing It's not a new processor. It's not an incremental advancement to computing. It is a fundamentally different way of driving computers. As a gross simplification, on a classic computer, you've got some number of bits of storage, and each of those bits is Boolean. They're a 1 or a 0. On a quantum computer, you have qubits, quantum bits, and each bit is a superposition of all possible states that that bit could be in. And by being really clever about how you collapse that superposition and measure it, you can cause the computer to execute programs that are effectively impossible to execute on a classic computer. You can effectively, when it reaches a branch, you can send it down both paths. And everyone that knows anything about quantum computing in the audience is cringing as I say that, but that's one mental model for how to think about this. One of the effectively impossible things that a quantum computer can do is break encryption. We know how to break RSA today. The security of RSA relies on the fact that breaking RSA would require all of the resources in the AWS Cloud from now until the heat death of the universe. And so we treat that as secure because it is infeasible to obtain enough computing power to break it. Well, in 1994, Peter Shor wrote a paper, and in that paper there was an algorithm, it's now called Shor's algorithm, which, if executed on a quantum computer, could factor large numbers in polynomial time. It makes it feasible to factor large numbers. And this is a total break for all of the asymmetric cryptography schemes, such as RSA, that are in use on the internet today. And these are the algorithms that are used to protect, for example, the key agreement handshake at the beginning of every TLS session. So if RSA, if Diffie-Hellman, if these things all fail, that's going to represent a significant risk to the internet. So what are we to do? As an industry, as a species, we have not yet determined this. There is no answer to quantum computing right now. We don't know what the timeline is for the delivery of a functioning quantum computer. We don't know when that's going to happen, what it's going to look like, and we have yet to determine what post-quantum algorithms look like. But it's actively being worked. The Computer Security Resource Center at NIST, 2 talks in a row. This is why I have a job, because if technology worked consistently every time, do I actually have to click through all of these? Ladies and gentlemen, I present Security Pioneers in turbo mode. Hopefully when they post this to YouTube, they'll edit this out, because I don't have that much comic material. Lambda, machine learning, come on, machine learning. We're catching up. He didn't break his leg on Oregon Trail? Woo! Actually, in the game of Oregon Trail that we played with my kid, I died. It was, oh man, and it's changed the layout. So we deal with all sorts of complex and challenging problems at AWS. And I am convinced that the 2 unsolvable problems in computer science are printing and presenting. Okay, I believe I was talking about the Computer Security Resource Center at NIST, and they're running a project on post-quantum cryptography. Their goal is to standardize a set of cryptographic primitives that are still robust and secure, even in the face of a quantum computer. And the first step here is a solicitation for proposals for algorithms. They received 53 submissions, of which 2, Bike and Psych, have Amazon employees as authors. Of those 53 submissions, 17 of them went on to the second round, and both Bike and Psych were selected for round 2. I consider myself an amateur cryptographer, heavy emphasis on the amateur. I started reading these submissions, and it made my head hurt. Post-quantum crypto is a fundamentally different field, and you should at least read the web pages for these things. It is absolutely incredible, the things that people are thinking of. So not only have we been involved with NIST, but we've been active and engaged with the community. Because we're going to have to roll these things out incrementally. There's going to be a transition period where quantum computers don't exist, but the crypto has to be robust and safe against quantum. But we're not going to want to lose the guarantees of the classic crypto that we've been using for years and years and we've developed faith in. And there's all sorts of trade-offs in terms of performance and network bandwidth. Some of the quantum schemes require like literally gigabytes of network traffic or many round trips. And so we're engaged with the community, with NIST, with other providers, with the cryptography community in trying to determine how we're going to roll out post-quantum hybrid schemes so that you get the benefits of quantum resistance and the classical security that we're relying on today. And I'm really proud to share that we just recently released support for Bike and Psych, our post-quantum hybrid schemes, in signal-to-noise, our TLS library. This is available now on GitHub. And if you'd like to play with it, you can go download it today and check it out. Right now, this is really for enthusiasts and cryptographers. This is not standards-approved crypto. It has been through some level of peer review, but it is nowhere near to the level of what I would consider production-ready. And over the coming months and years, as these standards gel, we will be adding them to S/N and then to our services as well, so that our customers can take advantage of them. So we don't have any concrete announcements here, but stay tuned. At Amazon, we love our Jeff quotes. We also love our old pictures of Jeff. And I believe this is from one of the shareholder letters. I love this quote. We use it all the time because it is incredibly easy for security to become a gatekeeper. It's my job to say no. Like, I have to tell people that the risk here is too large, we can't launch this. And in order to say no, you have to know about a thing. And so your instinct as a security professional is to add gates, to add controls, to add places where people have to check with you. They need a DNS name, they need a certificate, they need a public IP address. These are all opportunities to insert some security into the process. You want these gates and controls, but each of them is friction. One of my coworkers taught me to think about this like a chemical reaction. There's some activation energy that it takes to get the reaction started. And if you don't hit that activation energy, nothing happens. And so consider the case of a software developer. They're at home bored on a weekend, they've got their laptop, and they're trying something out, and they run into one of your gates. It's a rubber stamp. 100% of the people that have come to ask you for approval for this thing, you say yes to them. But now they're stalled. Like, it's the weekend, they don't have to work, they've hit a roadblock, they're going to stop, they're not going to ask, they're not going to follow up with you on Monday, they're going to forget about this idea, they're going to move on, and they're going to do something else. And you've just lost that value. And you can't measure that. There's no way for you to know that this software developer had a clever idea that would have turned into something, but they stopped because they ran into friction. And so we take this quote to heart. We think about this all the time in making sure that the friction that we're adding is appropriate, that we're unblocking innovation. People think of AWS as these, hopefully people think of AWS as these rigidly configuration managed AWS accounts, change management, tight controls on access. And that is absolutely how we run our production services. The AWS accounts that underlie the AWS services that you use, we watch like hawks, we raise the bar constantly. But I have a personal AWS account. We have customer service replicating customer problems. We have ProServe and our solutions architects embedded with customers, prototyping things and trying to help them solve challenges. And we have to enable those people to lean forward, to do interesting things, to solve problems that we haven't thought of, to use literally every single AWS service, every single feature, because some customer is going to be relying on it. And so we have to be able to secure things and let them do things. And so we need to keep up not only with the rate of change in AWS, but the rate of change in the world at large. New security research, new issues. And so we have to keep the security bar high, but we have to keep innovation and velocity high as well. And so one of the ways that I think about this is the business is going to take some curving path through space. I only had 2 dimensions on the slide, but the real path is much higher dimensional. And it's going to make bends and curves as the world changes, as new customers come on board, as new features get added, things like that. And you need to build an infrastructure that supports this business. And the further off from where the business is that you are, the more cost you incur, the more missed opportunities you incur. So there's some bounds within which you want to deploy. And the business is going to make sudden changes. Maybe there was an event in the world, an acquisition. The CEO read something on Wired, and now the press release is already out. And you're going to launch a new feature. Whatever it is, the business is going to change, and you have to react to that. But in this case, you're OK with overshooting a little bit. It was a sudden change. You're not sure what's going on. You're going to adjust as you go. Eventually, there'll be a security issue. Heartbleed, Spectre, Meltdown, pick your favorite. They all have logos and names these days. And in that case, your tolerance for an overshoot is going to be much more limited. You're not going to be willing to go past some boundary because that's the security issue. You're going to have to be able to react. And if the step size that you're taking, if the changes that you're making are large, it's going to be hard to map onto the business. You're going to have these agonizing decisions about where to aim that vector. And in reality, that boils down to which vendor should we use? How many of these should we buy? How much capacity do we need? How long is this going to last us? All of those questions, because you're predicting the future fairly far out. And as you go, you can do a pretty good job of mapping to the business, but you can see there's some mismatches here. And then when things suddenly change, maybe this change was already in flight. Maybe it was 80% deployed. And then you have the terrible decision. Like, you get all the VPs in a room. Like, do we roll the change back and then start rolling forward the new change? Do we allow this change to complete? Do we finish the deployment? It's going to take 2 weeks for it to roll out on the standard cycle. Do we accelerate that? All of these are hard decisions. And you're trying to map to the underlying changing nature of the business. Instead, if the steps that you take are smaller, then you can map much more closely to the business. You can be more responsive. If you make a bad decision and strike off into the wild, you're not going to go as far. You're going to have more opportunities to double-check your direction and to adjust. And you can get back on track. And then when the business makes a change, you can respond to it, and you can respond to it in a timely fashion. And the reason that we didn't do this in the old world was that each change was expensive. There was some minimum charge for making a change. And we wanted to amortize that across as much possible value. And so the change got bigger. And we talked about this in operations quite a bit in AWS. The changes get bigger, they get more critical, then you agonize about them more, which delays them, which people stack more stuff on, and it grows and it grows. So we talked about this with DevOps, but it applies just as much to security. And so this is something at AWS that we focus on relentlessly. And this is a theme that's gone through the entire talk, is figuring out how to take smaller steps, how to make incremental positive progress, forward progress, deliver value, learn lessons, reevaluate, and then take the next step. And so the net result is that replicating the results of others, experimenting rapidly, failing fast when you need to, doubling down when you can afford to be pioneers in an early wave, following right behind the explorers, becoming an explorer yourself when you run into something that you need to solve. You're not going to run out of oxen. You're not going to need to conserve rations. You're not going to die of dysentery. As a security engineer, I have never been faced with so many possibilities, so many opportunities, or been so well positioned to take advantage of them. And sometimes it seems like the job has lost its glamour. It turns into this constant stream of small releases. You don't have the big champagne moment, the party where everyone celebrates the massive launch. And it's incremental. It's without big bangs. And security is always endless. We wish we had more security engineers. I'm sure everyone else is in the same boat. But if you hired those engineers somehow, your job would not become more relaxing. You'd just dig deeper. You'd find more security issues to go tackle. You'd raise the bar higher. And so something happens to make you take a step back, like maybe a security conference. And you recalibrate. You think about the ways you used to do things. And you realize that things are happening so much faster now. The tools you have now are so much better than they used to be. And it's only because they crept up on you incrementally that you didn't realize how amazing things were. And you realize that life on the frontier in your air-conditioned, all-terrain, leather seat, cruise-controlled Conestoga wagon is actually pretty good. Thank you.